I welcome you all to the Spark Research YouTube channel. This is Dr. Veer Chandra, Assistant Professor in the Department of ECE. So this is the third part of this particular series, GATE 2025, and we are going to take more questions from this course, Electronic Devices. So for another remaining two more parts, you can find the link in the description section and you can visit, right? Okay, so this course is important, and the if you will focus on this particular course, it will be very easy to score the marks because you can easily score the marks up to 10 due to these simple subjects, right? So in this particular session, we are going to take the questions which is related to the PN junction diode, how the the current is flowing due to drift or diffusion and in the diode related. Okay, so if you remember the previous session, we have calculated the answers based on the drift current and the diffusion current, right? So drift current is basically due to the application of the voltage across the diode, right? We are applying the voltage, and the diffusion current is basically due to the majority carrier movement, right? So concentration gradient inside the diode itself. So diffusion is due to the concentration gradient inside, and drift is due to the external application of the electric field or the voltage. So this is your drift current, and here is your diffusion current. So if you add both of the current, and then you will get the total current which is flowing inside the diode, right? So if you will solve, then you will get the final equation like this. The current will be Is, that is reverse saturation current, equal to into exponential of Vd, that is voltage that you are applying across this diode, and divided by eta Vt. Eta is the constant which is ideally 1 for germanium, and Vt is the thermal voltage and minus of 1, and right. So Vt, if you remember, thermal voltage, that is KT by Q, right? So this is the final equation that can be used to find out the amount of current flowing in the diode, right? So just visit the previous session if you have not visited, how to find out the drift current or how to find out the diffusion current. And if you wanted to know how can we find out this final equation, this is also called the Shockley's equation. You can visit the theory portion where you can find the the total the first of all you have to find the concentration due to the drift, and then after finding the dn and dp you can find the current, and then you can add and you will solve, then you will get this total. Okay, okay, this is the basic of this session, so that's why I have discussed it. Now let's go to the question. So question is, an ideal PN junction germanium diode has a reverse saturation current of 10 microampere at 300 Kelvin, right? So there is a germanium diode, right, having the reverse saturation, that is 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 equal to 10 microampere. The voltage now to be applied across the junction means how much voltage do we need to apply in forward so that the current of 100 milliampere will flow. So V is the required, right? So V is equal to how much watt we have to calculate, right? So as for answer key, your answer should lies in the range of this 0.323 and 0.24, right? So again, how can we calculate? So we can use this equation, that is the current equation for this diode, where current will be equal to Is, that is reverse saturation current, and exponential of Vd by eta Vt minus 1, right? So what is this total saturation current? We have already discussed in the previous slide. Okay, so let's move how to solve. So in this question, what are the things are given? This is your normal germanium diode, right? So how much voltage we need to apply across this diode? Of course, the answer is 0.24. So how and so that your current should flow this much 100 of milliampere, right? And the reverse saturation current is also given, that is how much 10 of micro ampere. So reverse saturation current is given and the amount of the forward current is given. Just you have to find out the voltage, right? So this is the question. In another manner, like here is your germanium diode, so forward current, like how much will it propagate, the flow. So you have to find out. Reverse saturation current has given 10 microampere, and how will you find? So here is your equation: I is equal to I naught e to the power eta Vt minus 1. So use this equation, and here is your diode. So find how much voltage, that is V is equal to how much we need to apply in order to get this 100, right? So now these are the details, right? So I is equal to is qb divided by exponential of eta your vt. So kt here actually you can also write e to the power v by eta vt, right? So why v by eta vt? Because vt, that is thermal temperature, can be written as kt by q. So you can replace these values. And what is this eta? Eta is nothing, your ideally factor, which is 1 for the germanium diode, right? Other things like current is your forward current, is, that is the reverse saturation current, and then your K is voltage main constant, T is your thermal, the absolute temperature, Q is the charge of electron. So first we can find the thermal voltage, that is kT by Q. So yeah, it's the standard value is 25 millivoltage. We can put and get the values. After getting, you can put V by Vt, and then V is unknown, and here already you know Vt, that is 25 millivolt, and put the values already here. Is equal to 10 microampere, and your I current is 100 milliampere, right? So it has already been given, means 0.1 ampere. So now put all the values and get the value of voltage. If you solve, you will get V is equal to 0.24. So this will be your answer, right? So according to your answer key, your answer should be in the in the between 0 to 0.23 to 0.24. Okay, so that's all in this session. I thought to take more questions, but I found that this is the last question from this courses, so I left it. Okay, thank you for joining the session, and we'll come with some more questions related to the different subjects. Thank you.